Is glass liquid? Myths and reality. Is glass liquid? Many people don't even suspect that there are many objects and things around us that have amazing properties. In this article, we will discuss the hardness of some materials and the interesting results that are obtained based on these properties. In 1994, a large earthquake struck near Los Angeles, killing 57 people and injuring more than 5,000. The property damage reached an incredible $20 billion. Such earthquakes make us think. How hard is the ground under our feet? What does the concept of hardness even mean? Coal tar pitch seems hard, but it is not. In fact, it is a very viscous liquid, that is, it is liquid. Viscosity is a measure of resistance to spreading. Olive oil is about 100 times more viscous than water, and honey is 100 times more viscous than butter. The viscosity of pitch is 230 billion times greater than that of water. The longest-running experiment in the world is being conducted on pitch at Cleveland University. In 1927, pitch was placed in a funnel. Over 90 years, only 9 drops fell from it. No one was present when the drop fell. In 1988, the keeper of the experiment, John Mainston, was close to seeing the drop fall. He left the room to pour himself some tea and missed the treasured moment. You can watch this experiment online. But since the last drop fell in 2014, you are unlikely to see the treasured fall in the coming years. Another substance that is a viscous liquid is glass. Glass is unusual in that it is an amorphous body. Silicon dioxide molecules do not form an ordered structure. Glass cools so quickly that when going from a liquid to a solid state, the molecules do not have time to line up into an ordered crystalline structure. Glass appears solid because of atoms or molecules that are so strongly bonded to each other chemically that they cannot slide past each other. However, the lack of an ordered crystalline structure makes glass appear liquid, even when it is visually solid. It is because glass is actually liquid that in window frames in old houses, where the windows have stood for several decades, it is clearly visible that the glass is thinner at the top than at the bottom. This is due to the fact that some of the glass has already flowed from top to bottom over the years. Therefore, in such houses, the windows rattle in the frames, because at the top they were already thinner than the gap prepared for them. Sometimes this effect is so noticeable that even a gap forms at the top. Let's move on. What do we know about the interior of the Earth? Under the Earth's crust is the mantle, which is responsible for the movement of tectonic plates and earthquakes. Is it solid or liquid? We can never see the mantle directly, but we can see lava, which is hot rock. You can imagine that the mantle is very similar. The mantle must be liquid because it needs to flow, right? Actually, no, because the mantle is a solid. Earthquake waves can travel through the mantle, but these waves cannot travel through liquids, which is proof that it is solid. How does solid rock flow? The answer lies in the imperfections of crystals, which can be missing a few atoms. The viscosity of the mantle is like glass, only orders of magnitude higher. The mantle becomes liquid-like, but only on geological time scales. Pitch is a liquid that can flow so slowly that it appears to be a solid. And the Earth's mantle is a solid that behaves like a liquid if you wait long enough. Hardness and plasticity have no absolute meaning, only relative. And all bodies are in fact simultaneously liquid and solid. When there is a huge mass and force involved, the difference loses its meaning. The rigid definitions we create for ourselves lead to misconceptions and viscous rumors even.